When I embarked on creating my video about Milankovitch cycles, little did I know how fitting my analogy to Game of Thrones would turn out to be. In the TV show, the Night King's armies in the north are constrained by a colossal wall. Similarly, on Earth, there exists a formidable icy force to the north, yearning to break free and surge southward. This potent winter is held at bay by a mighty wall, allowing the nations to the south to experience relatively tranquil conditions. And just like in the TV show, that wall eventually succumbs to the overwhelming force of the ice, sweeping down and endangering the lives of all in its path. You may be wondering, where is this wall? And what is the frigid winter it shields us from? The answer to the first question is a name that has an intriguing ring to it, the polar night jet. And the icy winter it protects us from is none other than the polar vortex, a chilling force not to be underestimated. But what exactly is the polar vortex? And how does the polar night jet safeguard us from its wrath? My name is McColgan, and you are about to delve into the captivating world. Today, we will unravel the mysteries of this climate-altering phenomenon and explore the consequences when the polar night jet falters, unleashing the full fury of the polar vortex. Believe it or not, there are 2 polar vortexes, one at each pole of our planet. Furthermore, each vortex is composed of 2 parts, a tropospheric polar vortex and a stratospheric polar vortex. The tropospheric vortex spins within the lower section of the atmosphere known as the troposphere, stretching from ground level to approximately 10 or 15 kilometers in altitude. This region contains 75% of the total mass of the atmosphere. Above it lies the stratospheric polar vortex, a separate weather phenomenon with its own characteristics, seasonal cycle, and impact on global climate. These colossal cyclones sit atop the poles, rotating in sync with the planet and boasting wind speeds that can reach up to 240 kilometers per hour. But why do these powerful winds exist? The first piece of the puzzle lies in temperature differences. In locations like the equator, where sunlight is most concentrated, the air warms and rises, creating a region of low pressure that draws in air from its surroundings, akin to a giant vacuum cleaner. Conversely, in colder regions like the poles, air contracts and descends, generating zones of high pressure where air molecules want to disperse, similar to a crowd of schoolchildren released into an open field. With these opposing forces at play, there is a natural tendency for air to rush from the poles toward the equator. Consequently, freezing winds perpetually endeavor to escape from the north and south poles. However, it is essential to note that this model is somewhat simplified, as wind does not flow in a continuous line from the pole to the equator. Instead, the circulation of air follows 3 cells on each hemisphere. The polar cells, situated above the poles, and the Hadley cells, situated above the equator, both circulate in the temperature-driven manner I described earlier. However, the middle cell, known as the Ferrel cell, operates differently. It acts like a gear, dragged by the rotation of the other 2 cells, moving in the opposite direction. In the case of the northern polar vortex, as the air from the pole heads south, it encounters warmer winds traveling in the opposite direction. When 2 air fronts of differing temperatures collide, they clash rather than mix. Thus, the polar vortex becomes trapped, bounded, and confronts winds from all sides. But there is more to the story. If this were the only factor, the cold air from the north could simply slide beneath the warm air from the south, escaping without being truly confined. However, another force comes into play, redirecting these winds and transforming them into a swirling vortex that keeps them encircling the poles instead of venturing toward the equator. This spin is a result of the Coriolis force, a consequence of the Earth's rotation. In a simplified, flat world, cold wind from the poles would move straight toward the equator, while warm wind from the equator would travel straight to the poles. However, since our planet is a rotating sphere, any movement from the equator to the pole is subject to the Coriolis force, causing the air to veer to the east due to the conservation of momentum. The jet streams, which are powerful, high-altitude winds, are a manifestation of this eastward traveling air. There are at least 4 jet streams, situated between the Hadley cells, Ferrel cells, and the polar cells. Of particular interest are the polar jet streams, which encircle the frigid air masses that develop in the north and south poles. These ribbon-like currents traverse the globe in an almost continuous path, hovering just below the boundary between the troposphere and the stratosphere. They are only a few kilometers deep but can span hundreds of kilometers in width, with wind speeds reaching 400 kilometers per hour at their core. To put that into perspective, wind speeds above 120 kilometers per hour are considered hurricane strength. The jet stream encircling the South Pole remains relatively stable, forcefully dragging the polar winds that attempt to escape the frigid air mass, effectively encapsulating the entire polar cell within an immense vortex that spans across Antarctica. At this point, an astute observer might recognize a flaw in this model. If the conservation of momentum causes air traveling from the equator to veer eastward, why doesn't air traveling from the pole toward the equator veer westward in response to the zones with higher momentum? Indeed, it should quickly lag behind and appear to rotate westward. While this is true, the cold wind faces considerably more friction as it slides under the warm front and drags along the ground. This friction slows it down enough for the opposing jet stream to prevail. Nonetheless, it is crucial to acknowledge this dynamic tension, as it becomes more significant in the context of the polar night jet. The polar night jet refers to the jet stream that encompasses the vortex at the North Pole, particularly the stratospheric polar vortex. It serves as a safeguard during the coldest time of the year in the northern hemisphere, the polar night. During this period, the sun remains absent from the sky, resulting in even more frigid temperatures. Interestingly, the extreme cold intensifies the pressure difference between the air surrounding the pole and the air further south, strengthening the forces that give rise to the polar night jet. Consequently, the freezing air is typically well contained during the coldest months of the year. However, this containment does not always hold true. Various factors can disrupt the jet stream, such as coastal boundaries or the presence of large mountains, which can redirect the wind patterns. Even weather phenomena like El Niño, as you may recall from one of my recent videos, can influence the path of the jet stream. When the jet stream encounters such obstacles, it deviates from its course, setting off a series of oscillations akin to a bouncing string. It rocks back and forth, losing its equilibrium, and generates enormous planetary waves that cause the polar night jet to meander around the Earth rather than following a straight trajectory. In some instances, these oscillations can reach a tipping point, resulting in a breach. The initial indication of a breach manifests in the form of a sudden stratospheric warming, SSW, which commonly occurs in late winter. An SSW event can cause temperatures in the polar region to rise by as much as 50 degrees Celsius in just a few days. Something within the intricate system of the jet stream becomes disrupted, leading to the southward moving westerly winds overpowering the jet stream, partially or completely reversing its flow. Unleashed from its containment, the Arctic wind rushes southward, colliding with progressively warmer air and accelerating in an attempt to establish equilibrium. The entire jet stream undergoes a dramatic reorientation, descending upon regions like Europe and America that are typically shielded by the polar night jet. The forces of winter arrive with full force. To be fair, not all of these events have catastrophic consequences. With adequate preparation, one can simply don warm clothing or limit outdoor activities during the period when the polar winds dominate. As long as one is prepared for the cold, it does not signify the end of the world. However, there are instances where the outcomes can be severe. In the UK during the winter of 2009 to 2010, an event known as the Big Freeze brought temperatures as low as -22 degrees Celsius in parts of Scotland, the coldest in nearly 4 decades. This extreme cold resulted in widespread transportation disruptions, event cancellations, and power failures, tragically leading to the loss of 25 lives. Similarly, the January to February 2019 North American cold wave enveloped a significant portion of the United States in a polar vortex, bringing temperatures as low as -50 degrees Celsius when accounting for wind chill. Snowstorms raged, and exposure to the frigid conditions for just 10 minutes could cause frostbite. Tragically, 22 lives were lost, with hundreds more requiring treatment for frostbite. These chilling consequences were the result of a raging polar vortex. Over time, the imbalances in global temperatures realign, and the jet stream returns to its former position. However, it is worth noting that some level of jet stream disruption occurs in the northern hemisphere around 6 times per decade. If you reside in the northern hemisphere, you are likely to witness numerous such events throughout your lifetime, although hopefully not all as severe as the aforementioned examples. In the southern hemisphere, you are generally safer, as there have only been 2 recorded instances in history of the southern polar jet stream undergoing a breakdown similar to its northern counterpart. Nevertheless, it has happened, and the mechanisms behind it are not fully understood. With the gradual rise in global temperatures, it is challenging to predict the influence this may have on the jet streams. Some evidence suggests that the jet streams are shifting further poleward with each passing year, although such shifts have occurred throughout the planet's history. Additionally, there is evidence indicating that the jet streams have strengthened since 2002. If this is indeed the case, we should be grateful, as the biting cold of the polar vortex typically remains a temporary weather phenomenon. We witness its retreat within a month. However, if the jet stream were to vanish entirely, the polar vortex would descend from the north and linger, subjecting us to prolonged Arctic conditions. The more I learn about this subject, the more I realize the intricate interplay of forces and effects within the winds of our planet. They tug, pull, and find delicate balances while constantly shifting in rhythms and patterns. Yet, these phenomena remain largely invisible to us down here on the ground because air, fundamentally, is just air. Nonetheless, their significance cannot be overstated. The polar night jet is not merely a wind with an intriguing name, it serves as a bulwark of protection, a formidable barrier against the onslaught of freezing winds. It prompts us to contemplate the awe-inspiring majesty of the world surrounding us and how much goes on unnoticed, safeguarding us. If you have found this exploration of the jet stream and the polar vortex captivating, fear not, there is more to discover. Understanding jet streams was not always within our grasp, and there is an excellent article titled Searching for the River of Wind available on the website of our sponsor for today, Nautilus. Nautilus is a remarkable science publication that has left a profound impression on me due to its accessibility, compelling storytelling, and enlightening insights. Their esteemed authors encompass various scientific disciplines, providing cutting-edge research on a wide array of topics, including the one dear to the heart of every viewer, space. But don't just take my word for it, Nautilus is offering a rare 15% discount on their annual membership, making now the perfect time to experience it for yourself. Simply click on the link in the description below. Thank you for joining me on this journey of discovery. If you enjoyed this video, you'll undoubtedly appreciate our other videos exploring the diverse cycles of Earth. A special thanks to my patrons and members, you are instrumental in supporting my work. If you wish to have your name added to this esteemed list, please check the links below. Until next time, take care, and best wishes.